It is intended for information purposes only and may not be incorporated into any contract. It is not a commitment to deliver any material, code, or functionality and should not be relied upon in making purchasing decisions. The development, release, and timing of any features or functionality described for Oracle's products remains at the sole discretion of Oracle. Please welcome George Saab.
Hi, everyone. Wow, that was an exhausting run to get here. Whew. Welcome, everyone, to JavaOne San Francisco 2017. I'm very, very glad that we're back here in Moscone this year for the conference. Very pleased to see so many familiar faces. I've already seen a lot of you. I see a lot of new faces, too, which is great. And thank you all for coming. We have a lot of very exciting topics that we're going to cover today. This is an exciting time for Java. As you're aware, we've recently released new versions of both Java SE and Java EE. And this afternoon, you're going to get to hear a bunch of things about those. And we're also going to talk about some of the things that are in the future direction for Java. Over the past over 20 years, past 22 years or so, Java has grown, it's matured, and to the point where the ecosystem and the resources available are really unparalleled in our industry. And while Oracle plays an important part as steward of Java, Java's strength is really something that comes about because of a lot of people in the community getting together, working together, and collaborating in order to make it strong. Our first guests today represent a number of ways that people can get involved in the evolution of Java. And please put your hands together and help me welcome Jackie and Mercedes. OK, welcome. So our first guest today is Jackie Haynes. She represents Goldman Sachs on the JCP Executive Committee. So Jackie, why don't you tell us a little bit about the JCP and how it helps make Java strong?
Sure, thanks. At Goldman Sachs, we have around 9,000 developers working globally, writing critical applications for our business. And many of those are written in Java or run on the JVM. We've been part of the executive committee for the JCP since 2011. To me, one of the key ingredients to Java's continued success is the technical specification, and that's really unique to Java. And the JCP provides a way for us to take contributions to that. And that's really the key here, the community involvement.
OK.
And so that happens in two ways. One, we ensure the quality of that specification so that independent implementations can be written by other clients, other people who would like to get involved. But two, developers can propose their own features to Java, get involved in a JSR, and see that come to fruition as part of one of the new JDK releases. And my favorite example of that is the date-time API that came out in Java 8.
Excellent. Thank you. Our next guest, Mercedes Alvarez, comes to us from the Guatemala Java Users Group and also representing JDuchess.
Okay, yes. One interesting thing is communities are environments where we can share, learn, and grow up together as developers. And the JDuchess chapters are precisely that, but for the female sector. It's a way to can we grow up and increase the female participation in the community and in Java technologies. But the most important thing for me about the JDuchess chapter is that it's a way to change the future. Because every female that be part of the JDuchess chapter and having a role model in our society. So we are an example to what can be a women in technology. So we can inspire future generation for joint careers in technology and science. We can say to the world, things can be done in a different way and can be better. So that is me.
Excellent. Thank you. Thank you both very much. As you can see, Java's value stems from support and investment really across the industry. And just as Java is the result of broad collaboration, JavaOne is also something that happens through the efforts and the investment of a number of sponsors. Our next guest in this next section will actually have some words from one of those key sponsors. So I'm very pleased to introduce him. I think he has probably the coolest title I've ever heard. Please put your hands together and help me welcome the VP of Optimization from Intel Corporation, Michael Green.
Wow, this is a really big stage. Good afternoon, JavaOne. It's great to be back. You know, data is the future. Do you remember when self-driving cars and talking computers were seen as futuristic? If not, perhaps you should ask Alexa or Siri. When I was younger, I thought maybe, just maybe, in about 100 years, from then, this would be possible. Well, the world has exceeded my expectations. What I didn't understand as a kid was that data would be the key enabler of such a futuristic world. Data is to this century what oil was to the last, a catalyst of innovation and a revolutionary leader of change. Data is at the front and center of technological advancements, innovation, and business transformation across the globe. Let's take cars, for example. The data generated by cameras, LiDAR, GPS, and in the vehicle itself are essential to automated driving. We're looking at each autonomous vehicle generating approximately 4 terabytes of data a day. Soon, we'll be talking about data in terms of exabyte, points for what comes after exabytes, and zettabytes. Whether individual users or massive enterprises, At every level, data being generated will be exponential from where we are today. This is a total transformation across technology, moving from a compute-centric to a data-centric world. It's an exciting time. We view Java as a foundational technology to unleash the potential of data and bringing in this new future. It's why we're so invested and why we'll continue to be invested for years to come. We believe Intel and Java together will deliver on 3 imperatives created by this data explosion: speed, scale, and smarts. Speed. Performance is everything in a world where the difference between days and months can mean the success or the failure of a business. Or in extreme, like cases in medical treatment, saving a life. Scale. In a world with 20 billion devices as predicted in 2020 as predicted by Gartner, operating at scale is critical to managing their data and their businesses. And lastly, smarts. Artificial intelligence will be the tool that harnesses and converts a flood of data into powerful insights and smarter decisions. Increasingly, these insights will be made not only by people, but by the machines themselves. There's a movie of something about that, machines becoming self-aware. I'm sure you've seen it. So let's talk about speed. Speed naturally improves throughput, which often leads to a lower total cost of ownership. Let's take a look at what Intel's new class of Xeon processors can do for your applications in this video. So our newest hardware, the Intel Xeon Scalable processors, are designed to turn all this data into decisions faster than ever. With the Xeon Scalable platform, Intel is delivering an additional 65% performance boost over our last generation. This is the largest generational gain in performance in the past decade. For emerging workloads like AI, it means doubling the performance of the system. We've also worked closely with leading big data communities to optimize Hadoop and Spark for this newest Xeon platform. The result? A 3x improvement in performance. I stood on this stage last year and told you that a decade of accelerating Java has led to a 73x performance boost, and that we weren't slowing down. I also said that we would continue to add features into Java that matter to you. What I'm happy to say is that these efforts paid off. When we run financial services algorithms on JDK9, on our latest Intel hardware, Black-Scholes is 3 times faster. Monte Carlo simulation, 6 times faster. And for advanced encryption, up to 20 times faster. Putting it all together, our newest Xeon Scalable platforms and key optimizations collectively result in performance gains of 110x over the last 11 years. That's impressive. Intel and Java are simply better together. I hope you're all taking full advantage of what's possible with JDK9 on our latest hardware. Clearly, delivering performance is core to our business. We must also solve the problem of scale. From large data centers to the billions of devices and sensors on the edge, the data generated are growing at an exponential rate, creating a couple of challenges. First of all, data has to be stored and accessed quickly if you want to turn valuable business insights, valuable data into valuable business insights. And secondly, massive transaction volumes require a much more flexible and scalable application architecture. In a world where data is king, computing requires advanced storage and memory technologies. The first is Intel 3D NAND technology, designed to deliver double the capacity at a lower cost and at nearly half the power versus our first generation of 3D NAND. That's good, but we've done even better. Even more exciting is our new Intel Optane technology enabled by 3D cross-point memory media. This is our first memory media breakthrough since the 80s, enabling up to 10 times the density of DRAM. With this new technology, we are delivering a new category of SSDs called Intel Optane SSDs. And these devices really fly. We refer to them as the world's most responsive data center SSD. It's easy to understand why when you compare it to NAND SSDs. It's up to 8 times faster with 40 times lower latency. While that's great, we're going even further. Third, Intel persistent memory will bring the revolutionary Intel 3D cross-point technology that powers Intel Optane SSDs onto the memory bus in DIMM form. You can now remove the overhead of the file system, remove the overhead of the device driver, while keeping the byte addressability of DRAM, all while keeping the capacity and the persistence of SSD. This is the best of all worlds. As exciting as the possibilities are for this technology, programming persistent memory can be a bit tricky in Java. Number one, it's heavy lifting to maintain data structure consistency in a fail-safe way, and it requires access to low-level CPU instructions. To resolve these issues, we're happy to announce the availability of the persistent collections for Java. This provides you an optimized and easy-to-use set of common data structures, including persistent versions of lists, maps, tables, and sets. It also provides low-level functions for the power users amongst you. We have an early implementation of the library along with sample code such as a database example using persistent collections and a low-level API example. Please check it out. Try it in your applications. Let us know what you think. We're always happy to get your feedback. Your feedback is a gift. The demands of exponentially increasing data require you to scale across multiple nodes and clusters to manage it all. Whether you're delivering an e-commerce site, a streaming service, or a fantasy sports league, the challenge remains. To talk more about these challenges, I'd like to welcome a friend on stage, Chief Scientist of Alibaba System Software, Kingsum Chow. It's a long walk, isn't it?
It's a long walk.
All right.
Nice to see you again, Michael.
Great. Same to you.
Yeah.
What can you tell us about Alibaba's business and how you're dealing with the challenges of scale?
Well, that's a great question. We are dealing with the running with lots of Java applications and running about 100,000 Java applications and 1 million instances. But before I talk about that, I want to talk a little bit about Alibaba because some of you might not be familiar with what Alibaba is about. So let me get started there. Alibaba has a huge e-commerce site in China. In fact, if you look at the economy of our volume of sales, we are about the 22nd largest economy in the world, right behind Argentina.
That's impressive.
Yeah.
So what do you do to address the challenges at Alibaba?
Yeah, it's a great question. So in order to handle all the business we have been using OpenJDK and customized OpenJDK for our own needs. And as we mentioned earlier, we have huge e-commerce applications. We need to run and distribute them. Not only that, we also got some help from Intel.
Oh, you're welcome.
Yeah. So we ported several important patches about JDK 9 and put them down to the Alibaba JDK system we call AJDK. And it has been running very well so far.
Excellent.
So AJDK has been used to support lots of Java applications. In fact, I mentioned earlier that we have 100,000 applications written by 10,000 Java programmers. We have a huge presence in Java. And because of that, we need to customize some of the needs in Java. So we built our own JDK. And right now, we are running about 1 million JVM instances in our data centers.
Wow, that's a lot of data and a lot of compute. So did you have to do anything with the architecture to handle this?
Well, it's just a fantastic question. So in order to support the scale we need to deal with, we built something we call the distributed Java services on top of AJDK. And this means that our applications are modular Java services that operate independently of each other. And each Java service runs on a single process and is handled by a layer of communications among them. And these distributed services give us the agility and scale we need.
Wow, so what does that mean in practical terms for your business?
Yes. So let me look at one example here. Let's look at one single day in China. In fact, it's even called a single day. Some of you might have heard about that. November 11th has been redefined in China by Alibaba as the largest online e-commerce festival. And it's called a Singles Day because all these singles, they have nothing else to do, so they go online and take advantage of sales, and they buy a lot of stuff. It's very similar to Thanksgiving in the United States. So let's pull up some numbers and compare them, shall we?
Let's do
Okay.
that.
So last year, the total online sales in the United States on Thanksgiving Day, Black Friday, plus Cyber Monday, the total of the spending there is $12.8 billion. It's a big number. So look at China. People like to buy stuff in China for some reasons. So they generate sales in China on that day, $17 billion. And not only that, in fact, we need to process 120,000 payment orders at the peak of the shopping spree. So what does that mean? So to give you a comparison, a major credit card company that at the peak of the purchasing, they only need to process about half of what we need.
Wow, that's impressive. You know, in order to continue managing the growth of your business, what would you ask of the Java community?
Excellent. So 2 things. One is...
I'm the straight man, I think.
So one is, the better the hardware performance, the more creative we can be. We can distribute newer services, faster services. So we are very excited about all the performance you have mentioned today.
Hey,
we like all of them.
Intel processors always sounds like a good idea.
On top of that, we are also interested in learning how to use persistent memory in our applications. Secondly, as we mentioned earlier, that we are doing large-scale cluster deployment of our applications. So it would be great to have representative workloads for distributed services that we can model, play with, and then deploy in large scale.
Wow. Kingsam, thank you. Thank
You're
you
welcome.
for sharing with us Alibaba's challenges and challenging Intel and the Java community to do even more.
OK. Thank you. Nice meeting you. Bye.
So, as I already mentioned, when it comes to performance and speed, I feel like we're going to be able to take a done on that one. We'll continue to ensure, though, that Intel delivers the absolute best hardware for you and everyone else. to manage scale using distributed microservices. While we're seeing an increased focus on microservice-based deployments, such as the one Kingston described, today there's an industry gap when it comes to tools focusing on data movement and storage within and across the system. That's why today I'm announcing that Intel is launching DataBench, a new data-centric workload. The DataBench early release code base is available for download and collaboration right now on GitHub. While the proof of concept framework uses Kafka, Spark, and Cassandra, we've designed it in such a way that you can easily integrate whichever components you're currently using into this framework. Our goal is simple. We want to turn it into a workload that represents the reality of how you really use microservices. So come, help make it happen. So we talked about performance and scale. And now let's talk about smart. When I think smart, I think artificial intelligence. Society is being transformed on a spectacular scale. Machines that sense, reason, and act can accelerate solutions to large-scale deployments. Let's look at one specialized form of artificial intelligence, deep learning. It's fantastic in that it can be applied to big data sets and operate without human supervision for real applications such as image recognition, analysis, fraud detection, customer recommendations, and so much more. In other words, deep learning can be a powerful engine for producing actionable results. But there was a gap when it came to deploying deep learning solutions on the same Spark clusters that many of us are currently using to run big data and analytics applications. I'm happy to say that we introduced Intel's BigDL solution, a distributed deep learning library for Apache Spark, which, of course, runs on Java technology. Here's a video to demonstrate what BigDL brings to deep learning.
Organizations everywhere are developing deep learning applications to derive new insights, identify new opportunities, and uncover new efficiencies. Unfortunately, deep learning application development often means tapping into multiple frameworks, libraries, and clusters, a complex, time-consuming, and costly effort. Now there's a way to greatly simplify deep learning application development, decrease deployment costs, easily scale your applications, and achieve outstanding performance with BigDL. BigDL is a distributed deep learning framework organically built for Apache Spark. That means you can more easily develop deep learning applications as standard Spark programs using Scala or Python, and then run those applications on existing Spark or Hadoop clusters without expensive specialized hardware. Apache Spark enables applications to seamlessly scale across Intel Xeon processor-based nodes on a massive scale. And BigDL delivers extraordinary performance across the Intel Xeon processor-based infrastructure by leveraging the optimized Intel Math Kernel library. Plus, BigDL provides support for rich deep learning and delivers feature parity with popular open-source deep learning frameworks such as Caffe, Torch, TensorFlow, and others. Customers are already benefiting from the power of BigDL. For example, a major financial services firm has developed applications to strengthen fraud detection, and a leading manufacturer is pushing the envelope on improved defect recognition. BigDL could be deployed on a variety of big data platforms. Visit the link shown here to learn more.
Can't get tired of the bong. All right. So BigDL, as you saw, is an open source project. It's available on several cloud service providers, as you can see from the slide. In fact, it's not just theoretical. Companies like JD.com have deployed BigDL with remarkable achievements. BigDL has a growing list of applications and use cases deployed. We're encouraged by the uptake and different use cases being deployed. Please go check it out. We're enabling other capabilities as well when it comes to AI. Among them is the power of vectorization, which we've increased on our newest Xeon processors by adding the Intel Advanced Vector Extensions, AVX, AVX 512. Specifically, it can accelerate tasks like modeling and simulation. And at Intel, we've been building this kind of capability into our hardware since the 90s. But as we all know, it hasn't been easy to take advantage of it with Java. I'm happy to say that those days are behind us. And to share more about it, I'd like to welcome on stage Chief JVM Architect at Oracle, John Rose. It is quite a lot. Good to see you, John. All right. So, John, we've been working together on several things. Been doing pretty fantastic performance work together.
We sure have. Oracle and Intel have been collaborating for quite a while now on code quality, persistent memory, garbage collection, and of course the libraries, and as well as the vector hardware you just mentioned. I've thoroughly enjoyed working with Intel's brilliant engineers. And on all of these projects, we have gotten there much faster than we would have on our own.
You know, on that note, we've recently been working on some pretty exciting projects to give Java programmers new tools and programs for Intel hardware. Will you share with everyone what we've been up to?
Oh, I'd love to. As you know, Oracle's OpenJDK Project Panama was started to give developers direct access to their hardware. And now we have a new vector API in Panama that does just that. Complicated vector code that used to require JNI and assembly code, all that programming at the low level, can now be done directly in Java. For example, suppose I need to do some image processing. I need to quickly run over my loop with millions of pixels. Of course, I want to use Intel's vector hardware because it can work on multiple pieces of data at once instead of the usual single piece of data. This makes my code run as far as 16 times faster. Now, I used to write my data programming loops in classic Java. The problem was it didn't directly use the vector unit.
We should do something about that, don't you think?
Oh, yeah, in fact, we have.
All right.
In fact, with the Vector API, Java now unleashes Intel's AVX hardware, making it the ideal platform for accelerating deep learning algorithms, machine learning algorithms, financial service applications, scientific computing, you name it. We know that making it easy to add vectorization is incredibly important.
It sure is. So what does it look like to a real developer?
What does it look like? Like you, I'm a developer at heart, and I ask myself the same question. I think we should just show everyone here what we're talking about.
You want to see some real coding, real demos on stage? All right. Well, let's go walk over there and
I got a laptop here.
See what we can do.
We can hook it up to the screen and see what it shows us. All right, look at that. Now, this was done on top of the Panama Vector API. The idea is to transform the color of each pixel of this series of images. Now, for comparison, we'll do it the slow way and the fast way. First, I'll show you the slow way. This is the loop that works one pixel at a time. As you can see, everybody reads code here. This is classic Java. There's a 3x3 matrix in there, and it's doing a transform. OK, here's the fast loop that works with the Vector API, and it does 8 pixels at once. And you'll notice that the two loops look quite similar. This is no accident. It makes it easy to replace one by the other. With this code, I get direct access to the Intel vector registers and operations. Look at those vmol ps instructions in there. Aren't they beautiful?
Hey, let's see what it does.
All right, let's run this baby. All right, I'm going to press the button. I'm going to start up the loop. And what it's doing now is the images are being processed one at a time. Each image you see on the screen represents thousands of individual processing tasks. The gauges on the right-hand side show how fast it's going. And see how fast that top row went? Oh my gosh, it's already finished. Well, why don't we run it again? Meanwhile, the vector loop, the non-vector loop, the scalar loop, is chugging along, trying to catch up. Why don't we run it one more time? You know, these vector loops go really fast. You can get a lot more done in the same amount of time. OK, so which loop would you want in your application, right? And you are seeing this correctly. The gauges there show about a 6 times speed up. You know, this was really only possible because we worked together. And the future is bright for the Java ecosystem because of collaborations like ours. Thank you, Michael. Well, and thanks to Intel.
Thank you, John. It is great to have an incredible partner like John and Oracle. So to make this simple, we were really excited by what was able to be done. And in fact, we're so impressed that when I saw how powerful this Vector API is, that I told my team we needed to get it out to every developer right away, even while we're still in development. So I'm announcing the availability of the Vector API Developer Program, accessible today. Go to the URL where you'll find more extensive introduction to AVX technology written in developer-friendly language, meaning you won't understand it unless you're a developer. And you can check out John's image processing code as well. Wow, we covered a lot of ground on how Intel plus Java will enable the future. Speed, we continue to improve performance on our latest generation processors. Scale, we've added new storage and memory technologies to help address the challenge of computing at scale. Smart, with the addition of vectorization that you just saw and machine learning, we've made it easier to use Java to extract insights from vast pools of data. This was all done by providing improvements and code samples to help you, the developer, to quickly take full advantage of the increased platform capabilities. We have an opportunity to usher in a new world, a data-driven world. I look forward to collaborating with you in the OpenJDK community. We are better together. Thank you, and enjoy JavaOne.
Thank you, Michael, and thank you, Intel. Over more than 20 years, over 2 decades, Java has continued to bring value to developers and enterprises worldwide. Thoughtful evolution has helped Java grow into the most vibrant programming language on the planet. Moving forward, we want to ensure that Java is well positioned for modern development and growth in the cloud. And our next speaker is uniquely qualified to talk about how Java's future direction will help you through this transition. He was a lead developer on AWS at its inception, and he led development at Joyent for just long enough to have been cured completely of any Node.js religion. He came to Oracle then, and he architected the bare metal cloud. And now he leads overall strategy for Java and the cloud and container native. Please put your hands together and help me welcome Mark Cabbage.
Thanks. All right. Thank you, all of you. Thank you, George. Thank you, Intel. We are super excited to be here. Java and JavaOne really are by you and for you. And we have a ton of stuff to talk about. There's a lot of new content, a lot of fresh faces, including mine. And we're going to talk about the future, as George said, right? Because those stats that he put up, they're fantastic, but they're today. We need to be building for tomorrow. And actually, even if we take an honest look at where we are today, right, we can apply that actual famous Redmond quote that we all know and love, right? When web companies grow up, they turn into Java shops. That tells us something, though. It tells us that people are writing in something else first and rewriting in Java. We need to change that, right? Maybe it's Node.js, which apparently you can be reformed from. Maybe it's something else. But we didn't want the next decade to be Java first, Java always. Right? That's how we want you to think about it. So we're going to talk about how we're going to get there. So there's 4 themes we're going to come back to again and again throughout this keynote, and really that we're going to use as guiding principles for ourselves in the Java group. Number 1 is openness. Right? This is self-evident to technologists. Transparency is important in today's world. It's more important than ever. And actually, we're just going to show you about this. We're not going to talk about it that much. We need to evolve. Evolution is actually really hard, right? It's very easy to add things. It's hard to change things. It's nearly impossible to get rid of things, but you have to do it, right? The use cases that existed 22 years ago aren't relevant today. The things that exist a year ago may not exist next year. So we have to change. We have to get there really quickly. We have to be nimble as we do this, right? When we get things wrong, we have to get it right. We have to get it right quickly. Last, we need to continue to scale, right? And scale is easy for us as engineers to think about. Right, it's petabytes of data, or requests per second, or number of JVMs that you manage. But it's also about people, right? George had up that there are 12 million Java developers out there, which is awesome. But tomorrow we want there to be 1 billion developers. So that's the world we need to be building for. Let's talk about how we're going to get there. Start with Enterprise Edition. Right? This is huge news from us this year. 8's here, brings you modernization of the platform. There's amazing stuff in it. HTTP 2.2, async APIs, reactive APIs, helps you modernize the platform. But that's not good enough. Right? We actually need to do a lot more to modernize, to get you to that world of cloud and microservices and serverless. Because the reality is EE is the bedrock of mission-critical systems. It does power enterprise. And if we look at why it's not getting us there, actually, if we apply those themes, it's actually pretty self-evident, right? Is it open? Well, no, it's a vendor consortium. Last I checked, those aren't that open. And is it nimble? Well, it shipped 4 years ago. That's not very fast. So we're going to change everything about this, right? We put out this news a few weeks ago. People have been very, very receptive to it. We're super excited about it. We're fundamentally opening up Java Enterprise Edition. Right. Cool. So we're moving into the Eclipse Foundation, right? And we're going to change everything. We've actually gotten a lot of questions about this. I don't think people are quite clear. It's going to be everything, right? The reference implementations, the TCKs, that was a huge one people didn't expect. Authorship of specifications, importantly, control. We're going to be heads down over the next few months, getting to a 1.0 release there. But it's going to be, that's going to be a new day for it, right? That's going to set it up for the next decade to help us modernize. But I want to make sure you don't just hear this from Oracle, right? You've heard this kind of stuff from Oracle before. I want to make sure you hear it from all of our partners, right? So what I'd like to do is bring out 3 of the leaders of the EE community along with us. You hear all of us saying this together. So please welcome David Blevett from the Tomy Tribe, Ian Robinson from IBM, and Mark Little from Red Hat. All right, thank you guys so much for being here. So we'll kind of do this as panel style, so we all, we all say it together, brothers in arms. David, let's start with you, right? So you've been in open source for over 20 years. You built a fantastic career, a fantastic company out of it. What's your perspective on what this change means to the community at large?
Well, I think that when you look at our industry, we're filled with so many passionate developers, some of them quite young. The thing that I can't help but take away is you're inheriting EE. And so in a very real sense, EE for J is EE for the next generation. And the other thing is, collectively, you make the biggest investment in EE, which far exceeds what we collectively put in it. And so you having access to the TCKs, so that if you have a problem, you can go straight to the tests and get them improved. It raises the bar on us. So this effectively makes our largest investors enabled to fuel EE, and we can all go faster, I think, in the end.
Awesome. All right, so Ian, IBM, obviously one of the largest vendors, probably one of the 2 largest vendors of Java and Java Enterprise Edition on Earth. What's your perspective on what this means moving to the Eclipse Foundation?
Well, the Eclipse Foundation, I think, is a good choice. It's the one that IBM picked, for example, when we open sourced our J9 Java virtual machine. We've had, it's called J9, but it's actually been IBM's JVM since the Java 5 days. So I think having both the low-level JVM and the Eclipse and the enterprise platform, both at Eclipse, is a really strong endorsement for Java development, top to bottom, at Eclipse. And I think there's a couple of advantages I think that this has to people from a couple of different perspectives. David already mentioned the TCKs, access to the TCKs, which is great for developers. But for people building solutions on top of Java EE, I think having this new community fired up with energy, I think it gives them encouragement. I think that the future of Java EE is strong. And I think the only word of caution I would have is that having just open sourced OpenJ9 and our enterprise Open Liberty runtime, that took us a lot of work. That took us a year to get us there. So, there's a lot of work ahead, but I think we're going to be successful.
There is a lot of work ahead. We have a lot to do. All right, so Mark, Red Hat, obviously instrumental in creating MicroProfile, along with these guys on stage, a lot of people in the community. What's your perspective from MicroProfile and Red Hat on what this means?
I mean, you're right. We created MicroProfile over a year ago, moved it to Eclipse. We've seen a great groundswell in interest and participation since we moved it to Eclipse, for the very reasons that you mentioned earlier, that we can be more nimble and we can react to changes a lot more quickly. Moving E4J to Eclipse, I think, allows these 2 big communities to come together and help to drive enterprise Java into the next decade, as you mentioned earlier.
Awesome. OK, so what I want to make sure you all understand with all of us on stage is please come participate, right? We cannot do this alone. It cannot keep being a vendor consortium. So the charter's open at Eclipse Foundation. Please come check it out. There's a mailing list. There's a Twitter Foundation. There's a panel, which I'm sure will be action-packed right after this. Importantly, stop by the Red Hat booth, the Tomy Tribe booth, the IBM booth, the Eclipse booth, the Oracle booth. Please come talk to us. Please come participate. All right, thank you guys so much for being here.
Yeah. Thanks.
All right, so let's move on. Let's talk about Java SE. Right, so 9 is here. 9 is a transformational release for us. Right, it brings you over 150 new features, streamlines the JVM. Importantly, there's a lot of support in there for things like Linux containers, gives you better management, honoring of C groups, memory settings. Also, it has modules, which I'm sure you might have heard about. And modules really are this amazing thing that are going to let us turn the corner and let us evolve. Right? For you, they mean you can get just enough Java, just enough JVM in your life. You can right-size the JVM. Very important for a cloud world, for a dynamic world. For us, that means we can finally evolve the platform in ways we could not do before. We literally couldn't. So we think modules really are this linchpin that's going to get us to that future. But again, is Java 9 enough? No, it's not. Right? If we apply those themes again, let's look at those. Right? Let's talk about openness first. When I came to this group, what I was told was OpenJDK, that's a place, not a thing. That's not open enough. So now OpenJDK is a thing. Going forward, we're going to be producing OpenJDK binaries under the GPL license. You truly now have a free and open Java that you've never had before. That's number one. Number two, you might be saying, well, the OpenJDK, the Oracle JDK, one of those is better than the other. Maybe I have to use the Oracle JDK. Today, that's true, right? The Oracle JDK has commercial features in it. These things power some of the most gnarly systems on the planet. It's amazing technologies for help you run Java at scale. But today, they're only available to an elite few. And for that billion developers, they need to be available to everybody. So going forward, we're going to open source all of the features in the Oracle JDK. There will be zero differences between the OpenJDK and the Oracle JDK. That's. I got one more. Cool. So we truly now have an open Java, right? But it's actually still not enough because we think about pace, right? The last time it shipped was 3 years ago. That is not fast enough. So now that open, truly free Java that we just spoke about is going to come at you every 6 months. Right? So now this, we think, actually starts to change the future of Java. This, we think, starts to put Java in the forefront of everyone's minds, certainly ours, but also people that are not currently writing Java. We think this brings it to a new future that has not previously existed before. So what I want to do, though, is make you not hear this from just me, not from Oracle. I'd actually like to bring out Mr. Java Renaissance himself, James Governor from Redmonk, to give you his perspective. James, come on out.
I only have one slide.
You only have one slide? All right, good.
I'm not going to have a next slide moment.
All right.
It's fine.
Thanks.
Hey, everybody. How you doing? Pleasure to be here. The last time that I actually stood on the main stage at JavaOne was back in the distant past, back in 2004. So who all was here in the Java ecosystem at that time? Yeah, I think there's probably some of you that haven't quite admitted that you've been around that long. But I stood here and I said something that was kind of contentious at the time. I said that the JCP was the worst form of governance for software apart from all of the other ones that we've tried. Now, it's kind of interesting. We've seen this long path. I mean, at that time, obviously, Sun was still around. Things have changed pretty dramatically. And in fact, what I think is interesting is that things have changed in the Java ecosystem probably more in the past 3 weeks than they have in the previous 13 years. This open source move, I think we really can't underestimate the significance of it. If we're going to have a chance for the community to flourish, if we're going to have a chance to really expand, I think, the ecosystem, it was necessary that Oracle took these steps. I think one of the interesting things that's happened over the past few years is the adoption of Java by the web companies. So first generation web companies, I mean, obviously Amazon, very much a Java shop. Google, tons of Java. Obviously, they have Go and other languages now. But what's perhaps more surprising is those web companies that said, look, actually, we don't like Java. We're going to be Ruby. And, you know, Twitter, we're going to do Ruby. We're going to do Ruby. That was until Ruby wouldn't scale far enough. They adopted Java. Facebook, again, they came out from a world saying, oh no, we're not interested in Java, until they became one of the biggest Hadoop shops on the planet. So there's been a big change. But it's very, very important to those web companies that have an opportunity. They're all making open source contributions now. Things like in tracing, Zipkin, across the board, we've seen contributions. Kafka began as a project from, again, LinkedIn. So the fact is that you've got large web companies that want to make contributions. They want to be part of this world, but they haven't really got involved with Java because it wasn't as open as they might expect. They also felt that it wasn't moving as quickly as they might expect. You know, they're coming from a world of continuous deployment. Well, if you tell me it's going to be 3 years before the next version, they're not so interested in that. You know, developers tend to have a certain degree of ADD. They want something new. They want something bright, shiny, and fast. So, I mean, one of the things is, as Java developers that you want to think about is, where do we go from here? I'm either new to the ecosystem or I've been around for a while. How relevant are my skills? So Redmonk, my company, we do a programming language rankings. That is every 6 months we do it. It doesn't necessarily change that fast, so we've kept it at that time frame. And basically what we do is we scatter plot the conversations in Stack Overflow against what's happening in GitHub. And it's been very, very interesting to us at a time when a lot of people would say, oh, perhaps that Java was not as much a part of the new world you might expect, that it has performed with strength over time and continues. We generally see Java and JavaScript at the top of the rankings. There are tons of cool new languages out there. There's developers that are like, oh yeah, everything's going to be Rust or everything is going to be Go. Kotlin is this cool new thing in Java, but the simple fact remains that Java, the language, and not just the JVM, are a thing. So let's talk a bit about the JVM. I think, why did those web companies decide that they needed to adopt Java? Partly because of the skills. There are so many skills available. If you're hiring people out of computer science, chances are high they've got Java skills there. But it also gets back to something that I mean, you know, it's all very well and good to talk about, you know, move fast and break things, but who likes to sleep throughout the night? There you go. So I have 3 kids, and so I've had various times in my life in which I don't sleep through the night. But generally, you want something you can rely on, something that's stable. And what those companies found was that, in fact, in terms of observability, performance, traceability, and just the ability to manage something over time, Java and the JVM had a real value. There isn't really anything out there that replicates the power of the JVM today. So if we can accelerate the language development and begin to make it more like the modern developer expects, and that's what the challenge is for Oracle, then, you know, this sort of, there's plenty of runway to go. And I think that's the lesson. It was very important that the open sourcing happened. And we've got a new version of Java coming out. And that notion of a 6-month cadence is going to be a big, big deal. So hopefully in a couple of years, we'll be here. We will have had the low-hanging fruit done and a lot more development in Java, the language. Thank you.
Thanks, James. All right. It's actually super validating for us to hear that. I hope you're as excited about the future of Java as we are. What I'd like to do now, after hearing that from James, is actually move on a little bit and talk about cloud, right? Talk about Java in the cloud. As George said at the very beginning, there's 55% of JVMs today are connected in the cloud somehow. We need to build for a world of 100%, right? That's tomorrow, because cloud's pervasive. It doesn't matter what you work on, cloud is in your life if it's not already. Now, you come to conferences like this, or open world, or technology conferences in general, you're going to hear a lot about the business value of cloud, right? Things like OpEx and CapEx and elasticity. And all those things are true. Let's talk about what it means to developer to developer, right? Because this is a developer conference. To me, when you boil it down, cloud is about building a distributed system at the end of the day, right? And those are hard. They're actually super hard. It changes the way you have to think. It changes the way you have to tool. It changes the way we build, deploy, scale, operate our services. And so what I'd like to do is actually talk to you about what's in the ecosystem and what we're going to do in Java itself to help you in the cloud. What I'd like to do is make sure that we have a common frame of reference for this, right? Talk about one of those hyperscale web companies that James mentioned that we all think about. So they've never been at JavaOne before. They're a new face, as I said. There's going to be some fresh ones of those. But they're going to come talk to us about their architecture, the challenges they faced, what was hard, what's still hard, and importantly, why they've used Java. So please welcome to the stage Nicholas Gustafson. He's the principal architect at Spotify. Thank you so much for coming, Nicholas.
Thank you very much. Hey, thank you very much for having me. Spotify is a music streaming service. We aim to provide our users with the music they love on the platforms where they exist. Platforms that might include the ones you see in the picture here, but also embedded platforms like TVs or PlayStations or stereo receivers. We also want to give our users the features that they want in order to be able to discover and listen to the music they want. Since we launched in October in 2009 as a small Swedish startup, we've grown pretty quickly, and we're now in 61 markets around the world, having most recently launched in Thailand. We're at more than 140 million active users. But if you ask me, what I think is even cooler than that is that we handle more than 3 billion streams per day, and we have more than 4 million requests to our backend per second. Now, dealing with this scale turns into a pretty interesting and challenging technology problem, as you might imagine. Spotify started out as a Python backend. And you already met James, and you heard Mark mentioning this quote of his, and this is very much true for Spotify. While Python was an awesome way for us to get started and to build out our backend as we were a young company, we ran into some pretty constraining scalability concerns. We had one service, though, at the time that was implemented in Java. It was our search service. It's actually still around. We noticed that during the scalability incidents that we had, it behaved in a much more stable way than many of our other services. And the JVM had this nice property where we could actually observe what was happening in runtime. If that was collecting runtime metrics on the platform itself, or if that was profiling the service while running in production, both were very effective ways of knowing what was actually happening to the service. One of the very early and arguably the best decisions that we've taken architecture-wise has been to design our backend as a set of small, single responsibility, share nothing services. The pattern that is now known as a microservice architecture. As we decided to start exploring Java and a little bit later moving over to Java, being able to do that incrementally, service by service, as it made sense, was a crucial way for us to be able to do that change. Having small services also means that we can, as humans, easily understand and reason about them. We can scale them independently. Different features at Spotify has very different interaction patterns, and the services that powers the features needs to be scaled in different ways. It also means that we have limited impact when we actually have failures. So a service might fail for whatever reason, but only a subset of the feature set of Spotify or only a subset of our users might notice. Like if the search service would fall over, that will only affect search functionality on Spotify, not streaming or playlisting or whatever might be the case. And lastly, it enables us to have ownership of a service firmly within the team that builds that service. So you run what you build, and that closes that important feedback loop in between developers and operations. The picture on the right in this slide shows a very high-level view of our architecture. You can see the perimeter services, which are exposed to the internet. They're very hardened, and they manage things like authentication of requests to our backend and will route requests down to services further down. The next layer is what we call the aggregation layer. This is services that deals with things that are very close to what you would see in our clients, a one-to-one representation of the views in our clients. These services are stateless, and they don't do anything on their own, so they fan out to the lowest layer where we have services that do the actual data processing and storage. Then as responses get back, the aggregation services will create the view that we serve back to the client in a format that is easily consumable by our clients. All of this runs in a complete clone in multiple data centers around the world for us to be close to our users and have low latency, but also to be able to do full data center failovers during large-scale maintenance or incidents. And this is something that we do actually fairly frequently. We're not only using the JVM for our backend services, we also use it for our data processing and machine learning. Our data processing framework is based on Scala. It's called Xeon. It's been open sourced. It's a way to build pipelines that run on top of Google's Dataflow and BigQuery cloud products. We schedule these using another open source framework called Styx, which is a Docker scheduling framework. And this has enabled, similar to what I described from our microservices, for us to scale data processing and machine learning to the scale that we're at. So this is a logical equivalent to our microservice architecture, but for data processing. If any of this tickles your interest, I'll be running a session in just a few hours, so feel free to come along if you want to hear more details around how we think and build our backend services. And thank you very much.
All right, thank you so much, Nicholas. So if you've been in the space for a while, if you've been working on cloud systems for a while, you see that like an architecture of the sneak peek that Nicholas gave you, you realize we all have the same problems, right? We all have to build effectively the same thing to solve that same challenge again and again, right? We need this this thing that helps us get a distributed kernel, a distributed substrate. And if you don't already have one, and you're asking what should I build, or you have one and it's long in the tooth, and what should you do next? Our opinion at Java, our opinion at Oracle is you should use Kubernetes. Right? It is the right open source building block that abstracts away clouds, abstracts away infrastructures, gives you this distributed substrate to help you build resilient microservices. We're taking a big bet on it. We've put a lot of people on the Kubernetes project. We announced several Kubernetes-focused cloud products earlier today on the other side of the fence at Open World. We're doing a lot with it. We actually think it can do a lot for Java, too. So what I'd like to do is have you hear from a subject matter expert on Kubernetes why this is right for Java developers, why this is the platform you should build microservices on. So please welcome Craig McLuckie. Craig is the CEO and founder of Heptio. Heptio is a startup focused on bringing Kubernetes to the enterprise. But what makes him an expert is Craig was actually one of the co-founders of the Kubernetes project during his time at Google. So Craig, thanks so much for being here. Stage is yours.
Well, thanks so much for having me here, folks. It's really been an exciting 3.5 years since we started the Kubernetes project. And what we set out to do back in the day was to bring a lot of Google sensibilities around building and running applications to developers like yourself. I personally was really inspired by the idea of providing a better framework to run applications so that developers can focus on code and expert systems underlying the application languages could deal with a lot of the mundanities and challenges associated with running those applications. When we set out to start this project, we knew it wasn't enough to just write a letter from the future to enterprise developers. We knew that we needed to create something in the open and make sure that it worked as well with relatively traditional workloads as it did with the forward-looking, progressive, dynamic workloads that ran inside a company like Google. And so Kubernetes over the last 3.5 years has emerged as pretty close to a standard, and it is an open source container orchestrator. So for those of you who aren't familiar with it, it's worth just breaking down those 3 words. Open source obviously is critical. It's becoming increasingly important to organizations of all sizes. As they're making decisions about the technologies, they know that open source provides both an incredible force in terms of driving innovation, but it also buffers them from vendor lock-in, which is increasingly important. Containers have become an amazing way to simplify the operations process. As you're building applications, they provide a hermetically sealed, highly predictable unit of deployment. So you can take your application, in this case a Java application, package it up with all of its dependencies, and predictably deploy it out into a variety of environments, effectively decoupling it not only from the environment where it's running, but also in some ways from the operating system that it's running on. And that creates very high levels of portability. And then orchestration is the final piece. And this is where much of the magic is. by using a dynamic orchestrator, you can rely on an intelligent system to deal with all of those operational mechanics, deploying, scaling, monitoring, and reasoning about your application. Now, what this means to the Java community is actually pretty significant. If you think about the old world, you'd have middleware that would be responsible for running your mission-critical enterprise applications. What we're starting to see is that middleware getting teased apart, almost polarized into two different pieces. We're starting to see the emergence of systems like Kubernetes as a standard way to run a lot of the underlying distributed systems components, effectively stitching together a large number of machines that can operate as a single logical, ideal computing fabric. And then what we're starting to see is a lot of the other functionality getting pushed up into application-level libraries that provide a lot of the immediate integration that you need to run those applications efficiently. An outcome of that is pretty significant in that it now opens your Java applications up to a polyglot world. They can coexist side by side with applications in other languages if you want. But more importantly, it opens up them to an heterogeneous world where you can interleave these Java applications with a lot of dependencies that they might rely on. So you could run a Cassandra database, for instance, on the same core infrastructure using the same underlying orchestrator that your application uses, which is very powerful. What that means at the end of the day is that as you have a lot of enterprise concerns like governance, risk management, and compliance, you can rely on a simple, single, consistent underlying framework to deal with those problems for you. And as a result, Kubernetes is effectively creating this distributed systems operating system, a natural environment where you can run not only Java applications, but anything else. And you can do that in a way that is perfectly decoupled from your cloud provider. It works just as well on-premise or in the cloud. It gives you a great degree of choice and flexibility around where you want to run those applications. Now, as we look to the future, there are a set of challenges that exist when you're starting to move away from relatively traditional, large, structured applications into this more modern, microservices-based environment that Kubernetes naturally pushes you towards. The first and foremost of those is the weight of Java. If you want to move into this environment that is intrinsically more bite-sized, it makes sense to have a more bite-sized runtime environment. And it's very heartening to see some of the work that's being done to reduce the weight and spin-up time associated with Java so that you can actually get these more dynamic applications running. Another result of that intrinsic dynamicism is the need for higher levels of introspectability. You start to live in a world where your JVM, your Java application, is no longer tied to a single physical machine. So to really understand what's happening and to be able to diagnose things in these new worlds, you need higher levels of logging, observability. You need to have access to structured information about the application so you have a better sense of what happened after the fact without necessarily tying that to a single physical machine. It's also heartening to see some of that coming out in this very conference. The third thing that I think a lot about as we look at this environment and the needs moving forwards is the libraries themselves. As I said, Kubernetes provides essentially a distributed system environment, an operating system for applications. And while it is relatively unopinionated, it does offer up a certain set of primitives that are necessary to allow an application to find another application, access it, consume it. And I would love to see over the coming year or two a lot of focus on making much more natural Java runtime environment integrations with the underlying Kubernetes substrate. The final thing that I think about a lot when it comes to the Java community is a little bit nuanced. When many people start looking at Linux application containers, they think of them largely as a replacement for a virtual machine, just a way to package up and run something. But if you look back at their origins historically, they provided a very robust and rich resource isolation framework, a way to tease apart the set of resources that would be assigned to something and allow you to pack very densely a number of applications onto the same set of physical infrastructure. And one of the most heartening things that I'm seeing coming out of this conference is a lot of effort to make cgroups integration much more natural into the Java runtime environment. So I'm very excited about the future of Kubernetes. I think it's a very natural environment for you to run your Java applications. If you're interested in learning more, I'd encourage you to go to the website, kubernetes.io. And if you want to get closer to the community, feel free to take a look at the Cloud Native Computing Foundation, which is a vendor-neutral home where the Kubernetes project and a lot of new cloud-native technologies are being honed. Thank you so much for your time, and have a good day.
All right, so if you're one of those enterprises that needs to get some Kubernetes in your life, call Craig. Before we move on, what I'd like to do is give you some helpful information about how to get started with Java and Kubernetes. We put this together. So Oracle acquired them earlier this year. It's a fantastic container-native CI/CD service. Lets you get some containers in your life. Importantly, get some Kubernetes in your life. It's where we've launched all those Kubernetes services I mentioned. We've actually put together a curated set of Java getting started guide, tutorials, quick steps, libraries to help you get some Java into containers and into Kubernetes. So, by the way, there's a community edition, completely free, no strings attached. There will never be strings attached. So hopefully you find it useful. If not, let us know. If so, please let us know. All right. As Craig said, he spoke a lot at the end about observability and operations, which I think that's what we should talk about next when we talk about cloud services. Right? Because operations are fundamentally hard. They're one of the hardest parts of building distributed systems. And importantly, if you don't already know this or you've never done this before, think of them that way. Now, importantly, though, like observability, we always need more information. We need more insights, right? We can never have enough. Right? We have tons of data, but we need real-time information. As I said at the beginning of this talk, that we're open sourcing all of those commercial features in the Oracle JDK. One of those things happens to be Java Flight Recorder. If you're not familiar with JFR, JFR is this amazing, like, super Swiss Army knife that lets you diagnose any JVM or any Java application, right? You can see in real time what's happening up and down the stack. And you can do it with no performance overhead. So it's fantastic, but we need to help you scale in the cloud. We need to help you with this in the cloud. So what I'd like to do is actually give you a sneak peek at a service we're building in the cloud to help you manage JVM to scale, help you give you real-time diagnostics. So please welcome from my team, Varun Madden and George Matthew to talk about this.
Thank you, Mark. We're super excited to be here today and share with you all a service that we've been building for a while now. The service is focused on making container-native development in Java simpler, debugging any issues that you guys run into much easier, and just helping making your applications more performant. I'm sure almost everyone over here had to deal with profiling applications. And Mark kind of referred to this. Java Flight Recorder makes this really simple for a single JVM. But the problem grows as we move to the cloud, and even more to microservices, as we all are doing right now. The issue is no longer just what is my performance issue, but we need to know when it's happening and where exactly is it. So I would like to introduce a container diagnostic service that helps you do exactly that. This service runs in production. It's always on, provides real-time data with very, very low overhead. It gives you the depth of data that JFR provides and the breadth across the service. George here will actually give you a live demo of the service now.
Cool. Thank you, Varun. There's my screen. So a quick note about the setup for this demo. I have 3 replicas of my service running on a Kubernetes cluster, with the diagnostic service gathering continuous JFR recordings of my service. Now, one thing I'd like to reemphasize that Varun already touched on is that this diagnostic service is a very low overhead service that's designed to be running continuously in your production cluster. Because like he said, you don't know when the problem's going to show up, where it's going to show up, or that you even have a problem. Now, JFR has a lot of very useful and deep data, but today I'd like to focus on the issue of memory leaks. So if you look at this graph up above, it shows you memory usage by each of my pods right after garbage collection. And it looks like 2 of them are doing OK down here, but one of them's having a little too much fun and using up more memory than it should. Probably means it has a memory leak. Now, we do a lot of interesting analysis on this data that we gather from JFR so that we can find the problems for you and you don't have to go looking for them. So let's go look at this analysis tab to see what we found. And aha, we did find a memory leak. And as we suspected, it's only affecting one of our pods. JFR has this cool new feature that tracks the lifetime of a sample of allocated objects. And using this data, we can tell which objects are hanging around in the JVM for longer than they should. So let's dig in and see if we can pinpoint the source of this leak. It looks like in this case, we have some samples of a byte array hanging around for longer than they should. And if we click into an individual sample, we get very detailed information. We get a stack trace showing us exactly where in our code this object was allocated, and a reference chain showing us the chain of references that's preventing this object from being garbage collected. So let's go look at the code. So it looks like line 63 here of my appropriately named leak work item class is where I allocate this object. Let's go to line 63. Right there is where I allocate the object. No surprises there. Let's go back to the reference chain. It looks like this hash set right here in progress items is where I hold on to these references. And if you look closer, it looks like I do add these objects to the hash set and remove them. But it turns out that I forgot to override equals and get hash code in this class, which is causing the leak. Now, if you've ever had to troubleshoot a memory leak issue in production before, you know how incredibly difficult that can be and how much easier this is. And this is just the tip of the iceberg when it comes to the power of JFR. And we're excited to bring you all of that power to troubleshoot your production systems. Thank you.
Thanks, George. This was just a sneak peek of a small little thing that we demoed over here. If you guys are interested, there's a much more in-depth session tomorrow morning, 8:30. I know it's early in the morning, but believe me, it'll be worth your time. Thanks, everybody.
Thank you.
Cloud, which is serverless. Right? It's on everybody's mind today. And if you're not familiar with it, serverless is this compute abstraction that takes away all notion of infrastructure from you as a developer. Right? It applies to many things. It applies to compute, to databases, to storage. But importantly, when we talk about applying serverless to our code, to what we deploy, we think of it as functions as service. Right? And it's kind of a beautiful model, right? Because it lets you focus purely on the logic of your code, purely on business logic, not worrying about infrastructure, not worrying about that like muck that's in your system. And importantly, it gives you an amazing economic model, too. But again, having worked in the cloud space for a while, you look at this, and honestly, where we are in the space of the industry is actually pretty nascent, right? What's out there today is literally triggers for the cloud, right? Every cloud provider's got one of these things. Something like a VM goes up, a VM goes down, it publishes an event to a bus, you get some code that executes, you can take some action. It's super helpful, it's amazing for that use case, but it's easy to be tricked into thinking that's an app dev platform when it's not, right? The fundamentals of computer science are always with us, right? Things like concurrency and synchronization and state management, these are hard. For any reasonably sized application or reasonably sized microservice, you need something better to do that. And what you need to solve those problems is what Java was invented for in the first place, right? You need a language. 22 years ago, Java solved this problem. It's why it is where it is today for running on top of an operating system, whether that was Linux, Solaris, Windows, whatever. When we talk about the distributed operating system, right, that going to the cloud, we need a language to help us with those problems. So we're super excited to talk about what we're doing next. Right, we're going to talk about an open source project we're creating that is container native, completely language agnostic, but there's importantly an exciting Java layer that we're putting into it to solve those problems. So what I'd like to do is turn the stage over to Chad Aramura from my team to talk about what we're doing. So Chad, the stage is yours.
Thanks, Mark. My screen. I am super thrilled to introduce to you the FN project. The FN project today consists of 3 components. Number 1, the FN server. The FN server is the foundation of your functions as a service platform. It's what enables developers to build, deploy, and scale functions in a multi-cloud environment. It runs locally on your laptop, so you can get dev prod parity working locally, both in the cloud. It's fast, scalable, and container native. Number 2, we're announcing the FN Java FDK, or Function Development Kit. The Java FDK allows you to easily bootstrap your Java functions. It gives you a data binding model to bind the input to your functions to common Java objects and types. And finally, we're announcing the and finally, it gives you a test harness to test all of your functions using JUnit rules. So I don't want to forget that. And finally, we're announcing FN Flow. Flow is a system that enables developers to build higher-level workflows and orchestrate your functions in a more complex environment. You get things like sequencing and chaining, parallelism, fan-in, fan-out, error handling, state management, all from the language of your choice. Today, of course, we're announcing that Java is the first officially supported language. That's actually what I'm going to demo today. So in order to show this, we built a demo app called Vista. If you look at this application, it consists of 5 functions. And basically what it's doing is pulling images from Flickr of cars, detecting the license plate on that car, getting the actual value of the license plate using the OpenALPR library, which is an open source library. And then it uses OpenCV to draw a box around the license plate and send all of that information to both Twitter and Slack. As you can see, we have a number of red arrows here. And those are no-nos. That's where we have hard-coded invocations of each function from the previous one in order to call them. It's almost an anti-pattern when it comes to microservices and functional development. Enter FN flow. FN flow gives us a programmatic way to remove those hard-coded invocations and move them into their own function called a flow function. What we've done is decoupled all our functions from each other, and now we're back to the proper architecture for functional development. Let's take a look at some code. The first thing we'll notice here is that it's short, sweet, and simple. It's really a great thing. If you look at the top, we have our scraper that we invoke. There's a little lag here. Once we invoke the scraper, we get back a flow future object. That flow future object implements the standard completable future API that was introduced in Java 8. Along with that API comes a number of promises-like methods that gives us all the nice workflow that we want, such as then compose. Then compose adds steps to the compute graph and returns a future that represents the completion of those steps. Once we do that, we get basically the nice fan-out capability that I talked about before. So then we fan out, and we run the plate detection, and we also run draw. And once we're finished with that, we run all of, which gives us both the Twitter and the Slack function, which posts to those. And when it's complete, we have a when-complete method, which then tells us whether it was successful or it failed. That's actually something that I had no concept of before in the first version of Vista, because we had no concept of a complete workflow. So a couple things I want to point out. Of course, this looks like a single Java program. In fact, it can be reasoned about just like a single Java program. We can test it. We can use JUnit. We can put breakpoints. We have our familiar IDE. It's a single function code base. But behind the scenes, it's being broken up into sometimes hundreds, if not thousands, of function invocations. In fact, every step is a different JVM that we're running in a massively parallel environment. So you get all the benefits of a functions as a service system, such as the economic model of only getting charged for the milliseconds that these things are running, massive parallelization, and also the operational benefits without the complexity of dealing with a functions as a service system. And one other thing to note, any variables that were created inside the enclosed scope, whether part of the heap or the stack, gets reconstituted in all future invocations of any functions inside that scope. So it's a very powerful concept that no other workflow system gives you today. So I quickly plugged in the internet right as I came on stage. So we're going to see if I have internet. But we're going to try and run a demo. Yeah, I was on the Wi-Fi before. Don't ask me why. So if you look here, all I have is a simple payload.json file. It's just your standard JSON, 3 input variables, license plate, car USA. We're going to pull 20 of them. And because FN, the functions actually take standard in as their input, it's very, very simple. I can actually take that payload, and I can pipe it right into FN call. FN call is a wrapper around curl, which hits the server, which in this case happens to be running locally on my machine. And then my app name is my app, and it's flow. So once it starts running, the first thing we'll notice on the left is a number of functions are starting to spin up. We see that we already have a couple running. We have a number of complete. And in the middle, this is the flow UI, which shows here, I'll make this big, which shows the fan out. So at the top, we have, let's make this bigger. We can see now we're starting to fan out. This is a visual representation of all of the functions that are being sequenced and ran from each other, including a nice fan out capability. If I click on any particular node, for example, this one, I can actually view the entire call stack of how this particular function was called. This is really extremely powerful. It was composed from detect plates. Here's the log that I got from detect plates. I can view all the way down to the scraper, which is what the first function is in our sequence, all the way down to the flow function. And if we look on the right, of course, it's already finished. I wasn't able to show much, but we get all of our images in Slack, and finally, it's finished scraping. So I know this demo is extremely fast, but I hope that you got to see just a sense of how powerful the FN project can be and why we're so excited to announce it to the Java community today. Thank you.
So Chad, before you walk off stage, I actually have a question. This is going to be open source, right?
That's the plan, Mark.
Is it open source right now?
It isn't.
Well, it probably should be. Like, we're JavaOne. I say we do it.
Let's do it.
All right, open source the FN project right now.
Oh, there it is.
Here we go.
All right.
It's like we knew this was going to happen.
Well, I'm in the danger zone. All right. Hopefully my two-factor auth is off. Oh, no. Wait. Don't worry. That's an advertisement for 1Password. Boom. It's open.
It's open source right now.
Thanks.
All right. So please go try it out. We're really excited about where this is going. fnproject.io, by the way, if we didn't say the name. So please come try it out. Please give us feedback. Please come participate in it. Now, one thing I want to say about this, like the last thing I want to say on this, Chad showed you this demo. It's a super amazing demo. I get chills every time. But he talked about the completable futures API, right? And I think the way to think about this is, think of this as like a V1, right? This is our first step. When we talk about setting up Java for the next decade, imagine what we can do when we actually apply the language to this in a much bigger way, which is actually an excellent segue to the next of our talk. So what I'd like to do is now transition to talking about where we are with Java 9 and the VM, and where the language might be going. And who better to do that than the one you know and love, Mark Reinhold, the chief architect of Java. Mark, come on out.
Thank you, Mark. Hello, everybody. Welcome to JavaOne. Java 9 is here. That means, yeah. That means that Jigsaw is here. I heard those boos. In Project Jigsaw, we set out 9 years ago, believe it or not, to solve two fundamental problems in the Java platform. One is the brittle and error-prone class path. The other is the massive and monolithic JDK. I'm sorry, I need to interrupt right now and ask for the prompt screen to come up on one of the DSMs. Or I can just totally wing it. Yeah, I've done that before. At least it's not a demo fail. We'll get to those later. All right, thank you very much. No, I'm not done, don't worry. All right, so we have these two fundamental problems. We address both of these problems together by employing our standard recipe for evolving the platform. Identify the missing abstraction. Figure out what it ought to be. Add it to the platform in a way that fits it well with everything else that's already there. And of course, while doing that, preserve Java's key core values of readability, simplicity, universality, and compatibility. For these two problems, the missing abstraction, as we all know by now, is modules. What is a module? Well, it's actually pretty simple at a high level. A module is a set of packages designed for reuse. In Jigsaw, modules are a new construct of the Java programming language. They work the same way at compile time and runtime because they're known to both the compiler and the virtual machine. This greatly simplifies development. You declare a module in a module declaration. It's a little bit of Java code. You give your module a name. You name the packages that it exports for use by other modules, the modules that depend upon it. And you name the modules upon which it depends, whose packages it will use. Where do module declarations go? Well, they're Java source code, so they go in little Java files. By convention, these are named module-info.java files. What do we do with .java files? We compile them. You compile one of these files, you get a little class file. The use of class files here is intentional. It was somewhat controversial, but it's intentional because it makes it easy for existing tool chains to adapt to this new world. To package up a compiled module for distribution, all you have to do is make sure that the module info.class file is in your jar file, right there at the top level. Then you have what we call a modular jar file. So the module system helps escape from class path hell because it provides a cleaner and safer alternative to the class path. That is the module path. When you put modular jar files on the module path, the module system can guarantee two key properties when you compile or run your code. These are properties you can't even express on the class path, much less ask to be guaranteed. The first property is reliable configuration. Reliable configuration means if one module requires another, then that other module will be present, and none of the modules present will conflict with any others. As an example, here we have our module confu.lib again. Note the use of reverse DNS for the module name. That's a convention we're trying to establish. Confu.lib requires a module named confu.util, so the module system goes off and finds it and establishes the proper connection between them. Now suppose the confu.lib also required some other module called confu whatever, but there is no confu whatever. Well, what happens when you try to compile this module? At compile time, you get an error message. Error, module not found, confu whatever. If maybe confu whatever used to exist, but now it doesn't, at runtime, you'll get an exception. Module confu whatever not found, required by confu.lib. The second property guaranteed by the module system is strong encapsulation. Strong encapsulation means that code outside of a module can only access the classes and interfaces in the packages explicitly exported by that module. This means you can conceal your internal APIs and change them whenever you want to. To continue with our example, suppose there's some code in confu.lib that instantiates some secret internal class in the confu.util module. Well, you try to compile that, you'll get an error message. Sorry, that's not accessible. If you somehow manage to run it because maybe confu.util used to export that package, but now it doesn't, then you get an exception, illegal access error. And note, in these exception messages, we put a lot of information to help you diagnose what went wrong. So reliable configuration, strong encapsulation, this is a much saner world than the brittle and error-prone class path. The module system helps with the massive and monolithic JDK. That's because we've taken the module system and applied it to the platform itself. Starting with this spaghetti bowl of tightly coupled platform components, after years of painstaking refactoring, we managed to divide it into a set of 26 standard Java SE modules. I'd like to call your attention in particular to the Java base module there at the bottom. You might notice that there are no connections to the Java base module. I haven't drawn them in because every module implicitly requires the Java.base module. That's the module you always have to have. It has important classes in it like JavaLang object and JavaLang string. So all those connections aren't drawn, but base is always there. And of course, base does not depend on any other modules. The JDK, of course, has these modules plus many, many others, including modules for the standard development and debugging tools, service providers, and JDK-specific APIs. Since we have a modular platform, we now have modular Javadoc, which I'd like to show you. There we go. So this is the front page of the Java 9 Javadoc. It gives you some guidance up front. This is divided into 3 sections, SE, the JDK, and JavaFX at the bottom. You can see it's organized. This front page is organized by modules, so you can go click around. Let's look at the Java base module. Here we go. There's the base module. It's got a bunch of the usual stuff in it. Java IO, Java Lang. All those important things. We can go back, say, and look at, what's another, well, no, not that. Let's look at a more interesting module, java.sql.rowset. So sql.rowset is a more interesting module because it depends on some others. We can see that here the packages that it exports, and then later on we have in the Javadoc a specification of what are the additional modules that it requires in turn. And if you just want to learn at a glance what's going on, you can go up here, and there's a little hoverable thing here. You get the an image that's shown you, and this is actually generated by the JDK build, you can zoom in on it if you like, that shows you the subgraph of the module graph for just the Java SQL row set modules. It means if you require Java SQL row set, you're going to get all of these others. OK, if we can go back to the deck, please. All right, since the platform is modular, it's now scalable. Most applications, after all, don't need all of these modules, and now we can reliably configure consistent subsets of them. For example, if we have a module that just needs the Java.SQL module and whatever else Java.SQL happens to need, we can configure a custom runtime system that contains just those. All the other modules just fall away. We produce these custom runtime systems with a new tool in Java 9 called JLink. Java finally has a linker. It's an optional step, but it's a very important one. We can switch back, please. All right, so I packaged up a little demo here. Let's take a look at it. It's org open JDK hello, hello world. I know, very, very original. Let's take a look at the code. So this is a tiny little web application, about the smallest you could possibly make. Here's the main class, the only class, in fact. This uses the built-in ComSunNet HTTP server API. It's been in the JDK for a few releases now. Very handy if you just want to whip up a little app that talks to the web. I won't explain all the boilerplate here, but the important part is the method that makes the content. And in response to any request, doesn't matter what, it's going to build a little web page that says, hello, modular world, tells you what time it is, and gives you a list of the modules in the running image. So it's just using the stream API to get a stream of all the modules and then format them nicely. It uses the JavaSQL timestamp class just for amusement in order to show the time of day. Let's take a look at the module info. Here we go. Very simple module. It requires two others, JavaSQL, JDK HTTP server, and it doesn't export any APIs because, well, it doesn't need to. It's an application. OK, let's compile that. I've just prepackaged up the steps here to make it easy. Now we've got org open JDK hello.jar. We can look at that, and we see inside we've got just not only the traditional manifest, but our module info.class. OK, now I could run this directly, but what I'm actually going to do is run it in a Docker image. I'm going to make a little Docker image here. Here's a little Docker file that just runs this Hello World app on the class path using JDK 9. This is using the early access build of JDK 9 that you can get from Oracle for Alpine Linux, so it's more compact. Let's make that Docker image. Don't worry, the error message is normal. Goes off, it does the Docker thing, adds stuff, removes stuff. Da-da-da. Whoops, no. Let's run it. And let's see, if I go to localhost. Hello, modular world. This message brought to you by all those modules, only a handful of which were actually necessary. All right, so let's look at something. Let's do something better. Let's link a custom image. This custom image will have just the modules that we need. So I'm using the Alpine Linux build, the JMods from there. That's what the module path up here is specifying. I add the modules that I need. I tell it just for amusement that there's a launcher command named hello, and I do some compression and drop the header files and skip debug information to make it small. So I've got a custom JRE here. If I look in its bin directory, it's got a little hello command along with Java and, well, Keytool because. And it's nice and compact, 33 megabytes, right? Whereas if I look at my Docker images that I just built about a minute ago, it's 266 megabytes. Ouch. OK, so now I can make a Docker image containing just this. And that new image is a mere 38.9. Well, round up to 39 megabytes. And I can run it. And now we see, we reload this page. Ta-da! It's just the subset of modules, only the modules that we linked in. All right, if we can go back to the deck, please. OK, so the modular platform is scalable. And that's scalable in the technical sense, not the people community sense that Mark mentioned earlier. But it has additional benefits. Strong encapsulation means that we can conceal the internal APIs of the JDK. This makes the platform more secure by limiting the damage that malicious code can do. It improves platform integrity by ensuring that libraries and frameworks and apps don't depend upon the internals of the JDK. And finally, it helps make the platform faster. Link time is an excellent opportunity to do whole system optimization, such as resource compression, early verification, and ahead-of-time compilation, plus a whole slew of others. We've implemented some of these in JDK 9. There are more to come. We have a module system now and a modular platform. You might be wondering, well, what about existing code? Do I have to convert all my code into modules in order to run on JDK 9? No, you don't. Earlier, I described the module path as something that's better than the class path, but it is just an alternative. The class path is still there. In fact, the two can peacefully coexist. Jar files on the class path can even refer to APIs that are exported by modules on the module path. OK, good. So the class path is still there. It still works. But you might have heard Jigsaw breaks everything. That's not true. Jigsaw breaks some things. Remember, one of Java's core values is compatibility. We took this extremely seriously in Project Jigsaw. That's one reason why it took so long. If an existing application runs on JDK 8, and if your code only uses standard Java SE8 APIs, then it will most likely work on JDK 9 without change. I said most likely here for a reason. There are some minor differences. We removed a few obscure, rarely used methods and mechanisms to enable a clean modularization of the platform. Otherwise, it simply would not have been possible. We deprecated these ahead of time in Java 8. Now, what if your code does use some non-standard or JDK internal APIs? And by your code, I mean not just the code that you write yourself, but the code in all those libraries that you downloaded from Maven Central over the years. What if those libraries use internal APIs or depend on other internals? If your code depends upon JDK internals, then it may require change. Even though many of these changes are pretty obscure, they have affected some popular libraries and frameworks and tools. Happily, in many cases, their maintainers have already fixed them. I wanted to get an idea of what is actually ready to run on JDK 9 today. So I asked a question on Twitter last week. Do you maintain a popular Java library, framework, or tool? If it works fine on JDK 9, then please reply with its name and version. Thank you to everyone who replied. Here's a list. All of these things work fine on JDK 9. Probably a lot more stuff does, but these certainly do. There are some important things in this list. For example, all the major build tools, Ant, Maven, and Gradle are there. JUnit and TestNG are there. Essential libraries like Jackson, Log4j, Hibernate, ByteBuddy, and so forth. And the whole Spring framework itself, just released, runs fine on JDK 9. So I keep talking about internal changes. You might wonder exactly what do I mean? Well, let's look at a couple of examples. One is our old friend rt.jar. rt.jar is a zip format file. It's been in the JDK since 1.2. It contains all the internal classes of the JDK. This file no longer exists in JDK 9. It no longer exists because we replaced it with a file in a much more efficient format. And there was just no reason to keep it around. But there are a bunch of tools that read this. IDEs in particular use this to figure out what's in a JDK. So what we did was we provided a supported way to get at this information. There's now a NIO virtual file system at the JRT URI. You can open that up and grovel around in it, just like you used to grovel around in rt.jar. Another example is the Sun Security X509, X500 name class for manipulating X500 distinguished names. This has been around for a long time. There's actually been a standard replacement for it for quite a while. In fact, that standard replacement has been there since 1.4. Nonetheless, there are many libraries that still use the internal class. And the problem is all the Sun security packages are strongly encapsulated now. What does that imply in JDK 9? Well, in general, if your code uses JDK internal APIs, then it will not compile on JDK 9, and it may generate warnings at runtime. Now, wait a minute. You might be thinking, why won't I get errors at runtime, like you showed earlier for the secret class in confu-util? If I have a jar file built with JDK 8 that goes and tries to construct one of these X500 name things, why don't I get an error message like this? The answer is a lot of developers, deployers, and users just aren't ready. Migration takes time. Migration from bad habits especially can take time. So we've deliberately relaxed strong encapsulation of legacy JDK internal packages in JDK 9 at runtime only, so that old code will continue to work for a while. But I do mean for a while. Eventually, we want the JDK to enjoy all the benefits of strong encapsulation that I've mentioned earlier, so we will eventually re-strengthen that. So the addendum to this statement is, in a future release, code like this will not run. To help you get ready for that future, in JDK 9, there's a new tool called JDEPS that you can run on your own code. If you run JDEPS with the JDK internals flag against a jar file or a class file, it will go do some static analysis, figure out most uses of internal APIs, and suggest standard replacements if they're available. I highly recommend that you check it out. It's been a long road to Jigsaw. It's been a long road to design and deliver it. It will be a long road to its wide adoption, and that's perfectly fine. Many of you will make use of the newly modular nature of the platform long before you use the module system in your own code. Using module in new code is relatively straightforward. Modularizing existing code, however, can be a lot of effort, as we learned with the JDK itself. If you do modularize, Jigsaw does try to make it easier by providing tools to support both top-down and bottom-up migration. You can modularize your own applications before all of their dependencies have been modularized. And if you maintain a library or a framework, I encourage you to publish a modularized version of it as soon as you can, but not until all of its dependencies have been modularized from the bottom up. Jigsaw lays a strong foundation for the future of Java. It also supports the broader themes we've discussed here today. It's scalable, as we've seen. It's easier to evolve, and it's easier to evolve more nimbly. We can now remove entire obsolete modules. We can deliver new yet non-final APIs and incubator modules for early testing and feedback. And thanks to strong encapsulation, we can change the internals of the JDK whenever we need to. Jigsaw, of course, has been part of the open source JDK project developed in the OpenJDK community, so it's open as well. We received tons of valuable feedback along the way. Thank you, everyone who contributed good insights and experiences. And I'd also like to thank the long-term contributors to Jigsaw, who in some cases have been on this project for almost as long as I have. For more information, you can visit the Jigsaw project page in the OpenJDK community. There are links to all of the JEPs, the JDK enhancements proposals, and the JSR for the standard parts of the module system itself. My colleagues and I are giving a number of sessions this week. These are the times. They all happen to be in Moscone West Room 216. You'll notice that Prepared for JDK 9 by Alan Bateman was given this morning. There are likely to be repeats of all of these sessions. They just have not been scheduled yet. So pay attention to the online schedule, and you can probably still see it at some point. Alex Buckley will present the middle two, and I'll present the last two. For an even deeper dive, I highly recommend a new book just out from O'Reilly, Java 9 Modularity by Sander Mack and Paul Backer. It's a comprehensive and pragmatic guide to both the module system and the modular platform. And of course, there are other books that cover Jigsaw and 9, and they're either available now or will be very soon. So Jigsaw is here. It's part of Java 9, but it's not the only part. There are many other great features in 9, large and small. I'd like to show you a few of them right now. All right. So the first is JShell. I know I talked about it last year, but it's so cool, I just have to talk about it again. JShell is finally, Java has a redevelop print loop. Woohoo! You can type little expressions at it. You can declare variables and assign them values. It has tab completion. I hit tab right here, and it says, oh, there's a length method. You can invoke that. It can even show you the alternatives that you have at any given point. So here's substring, and now I can type 0,3 and just get foo. You get the idea. JShell is extremely handy for just doing exploratory programming, figuring out what's going on before you write actual code. Is that going to work? No, of course it's not. Is that? Yes. And it's got history. See, you can go back. Actually saves your history for a long time. Here's stuff I did like 3 days ago. OK, that's cool. So another cool thing in Java 9 is collection factories. How many people wish Java had literals for collections? Yeah, it's a pretty common request, going back many years. Well, we thought about how to do that, and it turns out there's no great way to do it. But we now have collection factories that make this much more convenient. If you just need to create a little collection that's got constant content in your code today, what do? Well, you do something really boring like arrays.as list of, you know, what do we do? Bar, you do this. You know, when you think about it, it's kind of stupid because it makes an array containing these two strings and then converts them to a list, and it's like, oh, well, that's dumb. Yeah, we can do that. What if you wanted to? What if you actually wanted to make a hash set? Well, you can do a new hash set. And yeah, that works. But oh, yeah, you wanted to make that unmodifiable because, well, it's a constant hash set. It shouldn't be modifiable. Collections dot unmodifiable set. Tab completion for the win. Now now it's unmodifiable. Even worse, suppose you wanted to make a map. How do you make how do you make a constant map? Well, there's no syntax for that. There's this really gross, dirty, ugly hack. Some people call it the double brace idiom. I'm going to show you this, but you have to promise not to use it. Oop. What did I do wrong? Oh, no. Oh, yeah, thanks. See? History is great. OK, I just made a hash map, but at what cost? I had to create, you know, there's an internal, there's an anonymous class created just for this purpose. Oh, geez, it's insane. So happily, we have a much better way to do this in Java 9. There are some convenience factories on the primary collection interfaces. I can now say list of. Ta-da, it makes me a list. I can say set of. I can even say map of. And there you go. Maybe not quite as slick as built-in language feature for it, but it's just about as good. OK, another cool feature is Javadoc search. You might have noticed that my browser got tripped up on this a little earlier. Let's go back to that Javadoc page. Javadoc now has a search box. You can type things up here. It doesn't talk to any servers. This is entirely in the browser. It shows that JavaScript actually is good for something. So suppose we wanted to see the Javadoc of that map.of method that we just used. It does search ahead, tells you all the alternatives. You can see here, if you look carefully, how we implemented like the first 10 combinations as explicit methods just to be efficient. But in the worst case, it'll take an array of elements. So map.of, click on that. Whoops, click on this. And boom, there you go. You can find entire modules. Suppose you wanted to learn about the new module, java.lang.module. Contains APIs specific to the module system. There you go. There's Java Lang module. You can scroll around in it, learn about what's in there. You can also, yeah, let's look at a couple of other modules. Oh, here's a popular module. So here's Korva. It's got its little graph. You can find out what things it exports, what things it requires. It's all that information is there. Now, something I'd like to point out about this is this annotation. The Korva module, as well as some others, have been deprecated in Java 9. We've enhanced the deprecated annotation to include a since value, identifies the release in which it was deprecated, and for removal. If for removal is true, that expresses the intent to remove this. So beware, Korva is on a limited lifespan. OK, if we switch back to the deck, please. Wrong device. OK, so that's just skimming the surface of some of what's in 9. Of course, to use 9, most people won't be like me and use Emacs in the command line. Most people will use an actual IDE. IntelliJ and Eclipse already support Java 9. NetBeans, I'm told, will support it pretty soon. To demonstrate how IntelliJ IDEA in particular supports Java 9, I'd like to welcome Eugene Petrenko from JetBrains. Hey, Eugene, what have you got for us?
Thank you for having me. So here I have a demo with IntelliJ, and currently I use IntelliJ 2017.3. This is an early access build, so anything can happen. OK, so this is a small application. It just prints hello world. It prints the version of the Java machine, and then it prints the module, which is associated with the class. As you know, in Java 9, any class is associated with the module.
Even if it's on the class path.
Yeah, exactly.
Yep.
So
a little tricky.
Yeah, and here have the really nice thing. This one is associated, this main class is associated with an unnamed module. And here's why. If we take a look closer on the command line, we see that IntelliJ still runs it with a class path. So exactly the same way as we tend to start our applications like for years. And to benefit from our modules, we need to turn this application into a modularized application. So for that, we can simply create the module info in the root of source folder, like this. So we call it some kind of org demo, for example. And in here, we have anything what we need, anything that we use to code completion. For example, it helps me to write anything I need, and so on. So if we turn back closely to my example, we have a compilation error over here. And the problem is that the MX beans are no longer in a Java.base.
They're over in some Java management module, right?
Yeah, right. So, and if we take a look on a highlight, so it shows us that we need to include this requirement to make it work. And instead of typing it manually, I can simply click here and say, please include it for me. And if we switch back, we see that there is now a requires that does the trick for us. So now let's start this application once more. So if I start it here, we see that the module of my main class is now exactly the same as specified over here. And if we take a look closer to the command line, what we have, we see that IntelliJ understands that this is a modularized application, so it uses the module path, -p for short, and a module to start it. That's it. And of course, dealing with one module is not that interesting, so let me switch to another example over here. So I have some more information here. And if it's tricky to understand what's going on here, I can just navigate between modules. For example, I can take a look into Java sources if I need some information or insight. For example, what packages it exports or what services it uses.
I recognize that module declaration.
Yeah. So, and if we need to take a look, like from the height, how my dependencies are. So I can do this one. So in a diagram, I see that my module depends on some 3 modules. There are some transitive dependencies, some static dependencies. For example, I can navigate over here and see that it's a static requires, that is transitive requires, and so on. So, and for example, if I decided to add some more requirements for my application, say I decide to use like that one, I can switch back and take a look how it looks like now. And if you take a look closer to this source file, you see this highlighting. This is a really nice feature of Java 9. And it's an ability to say in a deprecated annotation that it's going to be removed. So it's kind of verbose thing that IntelliJ shows us.
IntelliJ is figuring that out and striking this out to think about using something else.
But of course it would compile, but still it's quite verbose now. And you see the error over here in the right top corner showing that there is a problem here.
Cool.
Cool. And I really like this one. I tend to write Java code for years. And if I need some unmodifiable...
Wait, I told you not to use that.
Oh, really? Sorry. I'm gonna fix it now. Yeah.
Ooh,
does it look
automatic
better now?
refactoring.
Yeah.
Horrible idiom to a new API. Excellent.
Yeah.
OK, thank you very much, Eugene. That's great.
Thank you.
So Java 9 is here at long last. What comes next? To understand more about the future, let's take a brief look at the past. For 20 years, Java SE and the JDK have evolved in large, irregular, and somewhat unpredictable steps. Each release has had one or a few really big features, and the schedule of those releases has been adjusted as needed, sometimes more than once, in order to accommodate those big features. That's good for the big features. It gives them time to bake, but it's bad for the smaller features because that means it can take a long time to deliver them, even if they're ready long before the big features are finished. So we wind up with releases that are grand and majestic, but they're just rather slow-moving. For Java to remain competitive in this day and age, it must not just continue to move forward. It must move forward faster. That's why we've proposed doing a new feature release every 6 months on a strict, time-based model. In this model, features go in only when they're ready. If a feature misses the current release, that's OK, because it's only 6 months until the next one. It's not that big a deal. We think this is a good balance between fast enough to deliver innovation at a regular pace and slow enough to maintain a high level of quality. So the next feature release is 5 months away, March 2018. The one after that will be September 2018. The one after that will be March 2019. There will be a long-term support release every 3 years, starting in September of next year. So if features are going to go in only when they're ready, then we need a pipeline of features that we're working on so that when a release comes around, we can late bind to it and figure out, OK, what's ready? Let's put that in and ship it. We've been investing in that pipeline for years in the OpenJDK community. Here are some examples. Project Panama seeks to improve the connection between Java and native data and native code. Project Valhalla is about specialized generics and value types. Project Amber is about right-sizing language ceremony. And a new project, not yet proposed but being discussed right now, is Project Loom, which will aim to bring continuations and fibers to the Java platform to greatly simplify concurrent programming. To help us learn about one of these projects, please welcome Brian Getz, our Java language architect.
Hey, Mark.
Hey, Brian. So, Project Amber, what do you mean exactly by right-sizing language ceremony?
Well, as you might have noticed, Java has a bit of a reputation for being a little bit boilerplate intensive. Maybe it takes a little too much code to do a lot of common tasks. And so, Project Amber is really a collection of smaller features that are aimed at reducing the overhead or the ceremony of things that we do every day, streamlining, everyday coding, but also making code more readable and more reliable. And these are features that we can deliver over time, and I think a lot of them are a very good fit for the kind of programming models that are popular in the cloud, like the function as a service demo we saw earlier, or reactive event-based systems, like message-based systems or actors.
Right. So I know one of the sort of sub-projects of Amber is called local variable type inference.
Yeah.
What's that all about?
OK, so local variable type inference is a feature that we've seen in a number of other languages. But before, Java's had type inference for many years, and we've used it in some places in the language. And we've expanded the set of places that we use type inference over time. Type inference is basically just the compiler figuring out the type of something without you having to write it down. It can make code more readable by getting unnecessary information out of the way. And so this next iteration is simply extending that to the way we declare local variables.
Mm-hmm. You have an example, I think?
Yeah. So here's some typical Java code. The way you have to declare things in Java is you say the type first and then the name. But one of the things that we've noticed is that, at least in well-written code, the name is actually more important than the type, because it talks about how that variable, what it means in your program, not across all programs. And so if we allow the compiler to infer the type for you, well, the effect that it has is to sort of bring the name more front and center and puts the more important information where we can see it.
Like this.
Like this, exactly. So almost the first thing you see are the names. And of course, if you pick bad variable names, then your code will be unreadable. But I never do that either.
No. No, but this is not dynamic typing, right?
This is not dynamic typing. It's full static typing, that with the same static typing we've always had. It's just the compiler figuring out the type of thing from information that's already in your program.
Great. OK, when can we have this?
So it is already committed. This will be, this has been committed to the JDK 10 repositories. And should be shipping.
You mean 18.3?
18.3, yes, that.
Right.
And,
here's the actual commit message from last week, Maurizio's commit.
So it will be in a production release in March.
Excellent. That's very cool. So what else is going on in Amber?
OK, so the next thing I want to talk about is actually a much bigger feature, and it's a feature I'm really excited about. It's called pattern matching. So pattern matching is a feature that's been around, it's been associated historically with functional programming languages. And more recently, you've started to see object-oriented programming languages like C# and Scala adopt this feature as well. And we think it's a really good fit for Java. And so sort of to motivate what, why we think pattern matching is interesting, it has the ability to simplify the kind of code where you have to do multi-way conditional operations.
Right, code like this?
Code like this. So you're handed an object, whether it's a parameter or you've read it in from a socket, and it's going to be one of 10 different things, and if it's this, you do this, and if it's this, you do that. And this is how we write this code today. And on the one hand, there's nothing wrong with this code, because it's really kind of what you have to do. On the other hand, there's like everything wrong with this code, right? So it's verbose, right? It's repetitive. And the problem with repetitive code is it tends to be error prone. We do this by cut and paste. Was that a secret? Should I not say that? Yeah, so we do this by cut and paste, and it's easy to make cut and paste errors. And the repetition is really overwhelming, right? So not only are we saying, are you an instance of this, are you an instance of that, but after we do an instance of test, what's the next thing we do?
We cast it.
We cast it. Like, what else were you going to do, right? So there's a lot of repetition in this code, and as a result, these are places for bugs to hide.
We can do better.
We can do a lot better. So morally, the code on the previous slide wanted to be a switch.
Yep.
But switch is really pretty limited. Switch can only switch on certain types. It can only compare against constants. And so, if we enhance the switch statement to deal with patterns, which is what we've done here, we can make this code a lot easier. So the new thing that's going on here are these case labels. They're not constants, they're patterns. And a pattern is a combination of an applicability test, are you an integer, with some kind of conditional operation that you're going to do if the test succeeds. Cast it to an integer and bind it to a fresh local variable, which in this case is called I.
Nice.
And so already the code is becoming more readable, and it's more obvious what's going on because we've eliminated a lot of the cruft. But you can still see there's still some repetition here. We're kind of doing this in a very roundabout way where, since the switch is a statement, not an expression, we have to make an assignment in every arm of the switch statement. And it's easy to forget to do that in one arm. And if your tests don't have good enough coverage, you just have a bug that's lying around. So we can make this example even better by turning switch into an expression.
Like this.
Right, exactly like this. And so now this is probably the code that you had in mind when you were writing the code on the first slide in the first place, but you couldn't write it like this, so you had to write it in this very roundabout way. So this is code that's more readable, more maintainable, much less error prone, and as a bonus, faster because the first code was a linear chain of tests, but by expressing it as a switch, the compiler can turn this into a decision tree, and it's probably going to be faster as well. So less verbose, less error prone, faster.
Great.
Trifecta.
So patterns are cool, but these seem fairly somewhat limited. Can they be generalized to bigger cases?
Yeah, so this is a really simple example, but more commonly when we're called upon to make a multi-way decision, we're handed complex objects, which we're going to destructure and take out their state and then do something with. So as an example, like let's say we have a hierarchy like this, where you have a shape, and you have circle implement shape, and it has a center and a radius, and square implement shape, and it has a corner and an edge, and let's say we want to calculate the area of one of these things. So we know it's going to be one of these three things. We know we're going to have to take them apart. So we can use what are called destructuring patterns to rip through all the boilerplate that we would have had to write, right? I mean, so if we were writing this the old way, it would either be big, nested, ugly if-else, or even worse, visitors.
Yeah. Oh.
So pattern matching lets you express this in the sort of direct way that you want it in the first place. What we're saying is we're switch on the shape, and we're saying, is it a circle? If so, cast it to a circle, extract its center and radius properties, and then use that to compute an expression for the area of the circle, and similarly for the square, and similarly for the rectangle. So it's kind of saying what you mean without all of these layers of boilerplate.
Very nice. Now that's a much bigger thing than VAR, right? So it's going to take some time to do this. How are you going to do this, given that features are only going to be feature releases will only be 6 months apart?
So we're going to break it up into smaller pieces, right? The first example we showed with type test patterns, we can do that first, and then we can add more different kinds of patterns, more different places in the language to use patterns over time.
Although in a way it makes the job harder because we have to be really sure that we're laying the foundation for the thing we ultimately want to do.
Yes, we do.
Yeah. All right. Thank you very much, Brian.
Thanks, Mark.
So Project Amber is just one example of the long-term investments we're making in Java. There are other large projects, not just the ones listed here, but many others. There's a continuous pipeline of smaller features that are smaller, but no less important. We hope that all of this work will not just keep Java moving forward, but moving forward faster. Thank you very much.
All right, thanks, Mark and Brian. Well, as promised, you got to see a lot of interesting things today, and there's a lot more interesting stuff to happen at the conference. One of these things I will mention tomorrow, there is the Oracle Code keynote. It's at 4:15 at the Marriott Marquis, and you won't want to miss this. Patrick Dubois is generally regarded as one of the founders of modern DevOps, and Buster Benson is from Slack. Please go and check it out. It's free for all JavaOne attendees. Thanks, everyone, and enjoy JavaOne.
I believe every human being is a potential coder.
Quizzical mind, somebody that likes to solve puzzles.
Someone who can work within a team.
I think you have to be quite meticulous.
You have to persevere.
Intelligent enough to understand the logic of the code.
Have empathy for their users.
The first thing is patience.
Likes to solve riddles. A good coder is someone who can think through clearly and implement their idea into code.
10 years ago, we were coding for computers, but now everything is a computer.
A lot of the redundant and rudimentary stuff we do as a developer will be taken over by these automated processes.
Things like human brain interfaces and machine learning and neural networks.
Potentially a new language that
doesn't even exist yet.
Still believe we have a bright future, despite self-driving cars and artificial intelligence.
Interacting with a keyboard-less layout.
I think we're going to see a lot more voice interaction with devices.
Hopefully not computers coding themselves. This would be like, how it's called, the singularity, right?
I code because I love coding.
I code because I love, for me, it's like a brain puzzle.
Because I'm a builder, and I ran out of Lego bricks.
There's a lot of creative juices that flow when I write code.
Because I like making things, basically.
Coding is fun. It's a fascinating, wide open field where you can do anything you absolutely want to do.
Having a problem that you turn into a solution through code is one of the most beautiful things in a job that I can imagine doing.
So what is ERP? And how can it help your business? ERP stands for Enterprise Resource Planning. Companies have relied on it since the 90s to streamline processes and improve data visibility around finance, project management, and manufacturing. However, the cost of ownership began to climb significantly, and on-premise ERP couldn't keep up with modern security demands or technology trends. So, ERP evolved to embrace the internet with new features and functionality. Enter ERP Cloud. The cloud offers a more affordable alternative for ERP because it eliminates the need for software and hardware or additional IT staff. ERP Cloud enables organizations of all sizes and across all industries to make significant cost savings, improve business insight, enhance collaboration, and increase efficiency. Oracle ERP Cloud is built for the digital age, delivering on the promise of the end-to-end process, visibility, and speed, all at a lower cost.
Opera Cloud is the next generation of hospitality products. What we're being able to do now is leverage new technology, both on the database tier and application tier, to really empower the hotelier with new screens, new flow, new functionality, soft design, more intuitive, with the ability to capture the millennial employee that's utilizing the system in a look and feel that they're used to. With the Opera Cloud deployment, you're really looking at being able to reduce a big IT footprint and cost. Opera Cloud lifts all of that up, so now we're taking that ownership and we're putting it within our four walls of our data center, where we're running Oracle products on Oracle hardware provided to you in an Oracle data center. Let's get that into our space where it's got security, it's got redundancy, it's got failover, it's going to be upgraded automatically, and we remove the annual support cost that you're used to paying, and we wrap that all into one SaaS, software as a service fee. What we've noticed is that the IT costs go down from an operator's perspective. Think about the training aspect. The training aspect should decrease significantly, and then think about all the integration points around it, right? When we look at the cross-training perspective, or we look at a cluster of hotels that are all in the same city, and you can pull resources from Hotel A and put them over in Hotel B, the front end of the application, the similarities in configuration, it's all there. Whether you're checking in a guest at one property or the other property, the flow is 100% the same. It's the ability to customize your application for your independent property. So turn on parameters or functions that are specific to you, right? You don't necessarily need to take an off-the-shelf product and use it in an off-the-shelf way.
What we found through our own cloud journey is when HR and finance collaborate together, everyone wins. To really look at HR and finance and how the collaboration between these two areas can really help an organization in their transformation to digital. What that study showed us was that HR and finance, when they work collaboratively together, can not only find their cloud path, but more importantly, exploit it. There's 35 different processes that we see a finance and HR need for integration. Skill development, the people development, the management of change, the organizational restructuring. Now in a cloud-based environment, both HR and finance can reap the opportunity of having a much stronger underlying system that can serve a shared service environment. It really allows us to have a single source of truth. We're creating the information once and we're using it many times. The business wins, HR wins, finance wins, IT wins, and because we're here to serve our customers, we believe the entire ecosystem wins.
The bad news is IT's not keeping up with the business. Bro, the business needs to chill.
The good news is the CIO's ready to fund a hardware refresh. So I want the two of you to figure out the best way to run our Oracle database.
Us two together? So what do you think about Oracle Database Appliance? It's purpose-built to run Oracle Database Plus apps.
The what appliance?
Oracle Database Appliance. Basically, it's a complete Oracle database environment. Compute, OS, networking, and storage. And you can set the whole thing up in 30 minutes.
Yeah, but what about networking? And storage?
I literally just said those words. Dude, I definitely found our new solution. With Oracle Database Appliance, patches and quarterly updates are automated and pre-qualified.
I can do that stuff in my sleep.
Yeah, but remember when you forgot about that security patch? Hey, I was thinking you totally jammed on that last deployment.
No doubt.
So why don't you make your recommendation, I'll make mine, then let the director choose.
14 minutes? Bring it on.
To sum up, Oracle Database Appliance is simple, optimized, and affordable. It deploys in minutes, it requires fewer resources, it provides a path to cloud, which future-proofs our IT investments. We reduce expenses with capacity on-demand licensing, which means we pay as we grow, and it starts at a very affordable price.
Impressive. So what have you got, Dave? So how does Oracle Database Appliance provide a path to the cloud? That's going to be key for the CIO.
It's architected for the on-premise world, but also engineered for hybrid cloud environments. So it's really easy to do backup and disaster recovery. We can move workloads like dev tests to the Oracle Public Cloud.
I think you and I are ready to take this to the CIO.
Let's go. Oracle Database Appliance. Simple, optimized, affordable, and ready for the cloud.
Our vision is 100% slave-free chocolate. One of the major challenges we face is to have enough beans for our 50% year-on-year growth. The backbone of the company, the supply chain and the IT systems did not always catch up with the growth. We will be using a planning and budgeting cloud service to roll up all the data from all the countries in order to make the right amount of products in the right flavors for all the countries to supply them with. I would definitely recommend cooperation with Oracle because although they are really a multinational, they are really able to work closely to a medium-sized company as we are.
Prior to implementation of Oracle Planning, many of our systems had been living with us since like 2005 or prior. So when we decide to implement Oracle Planning, the first and foremost, it's all about integration, that now the data is flowing seamlessly, automatically, and no single person copying data from one spreadsheet to another. The implementation of visual line planning, in my opinion, is really the integration between art and the science. We had Adobe tools beforehand for all the images. Then someone physically, manually copy-paste images into Excel spreadsheets just to make it look useful for the further processes. Whereas the visual line planning now is an integration between our PLM solution that hosts all the product images. So all the images automatically flow into the visual line plan solution. So as you come in to the system, you start planning your line at a master style level, at a style level, and a style option level. So on all those levels, depending on how you create images, and it's not just one image per style. So you could have multiple images, and then the system would pick up all those images, and you can see it visually in the tool as you are planning. Products coming into the store, it sells through for the next 4 to 6 weeks. By then you get the next new flow into the store. So you could see all the flow very visually, and you can adjust accordingly, if it doesn't look right, which is a huge benefit. As images change or getting updated, we automatically pull all those as part of the planning process. It has really brought together our global planning, global merchandising team in Vancouver, and all the regional buyers in Europe, in Asia, and Australia.